Okay, so we are going over a recording on paragraph 6b, numerical data. So we are recording, guys, keep it down, please. So here we're looking at numerical data. Numerical data is data that takes values which are numbers, right? What kind of data did we see yesterday which doesn't take values which are numbers? Categorical data, exactly. So yesterday we saw categorical data. So here we're looking at numerical instead of categorical data. Now, what do we do with this kind of data to present it to someone, to show to someone how much we have? Well, for example, here we've got number of people, right? We saw this yesterday. We saw how we create a tally and how we convert the tally into frequency. So we saw this. Now, this would be a frequency table. Now, we want to show how do we present this data to someone. Well, we can easily do that using a column graph or a dot plot. So I would say dot plot in real life, we don't tend to use too much. Dot plot is something to help us understand this topic a bit better. We introduce it in school, but I would say in real life, we tend to use column graphs a bit more. So if you work in a company that says, all right, let's see, guys, how did we do with sales this month? Let's have a look at the column graph. Okay, so you can see had the most sales this month. So he sold about 13, and then maybe was second here with 10, and then maybe we had here or somebody else, or maybe let's mix it up. Let's say had the most sales, right? You see the point. Basically, this might be something that helps us compare and say, actually, you know what's happening here? Maybe this is how many times you go to the bathroom. Oh, you went to the toilet 13 times in maths. What was up with that? But you know, PE, you never went to the toilet there. Could it be that you're trying to fool us? So anyway, this is a presentation of the data. So it shows us the frequency very easily, or we can do that using dots. Dots obviously can not be as accurate. Maybe we'll make a silly mistake with the dots and it's not going to look too much, too correct. But notice something we can pick on very, very quickly. We can pick something up here. What is that? It's an outlier. What is an outlier? It's something that really stands out from everything else. Something that's not quite the same as everything else in our data. Let's have a look at this data we've got on the board. What looks like an outlier here? Can you see in our data down here? No. Yes, outlier. Outlier is something which is very different from everything else. And saying, look at this. Yeah, it stands out so much, right? And let's have a look at the dot plot right here. So this presentation helps us find if there is an outlier. So say, for example, I want to check out the average height in this classroom, and I notice the average height is 130 centimeters or 140 centimeters, something like that. Actually, can somebody tell me your height so I can get it right? Yes? 170? 166? Okay, so let's say your heights are between 160 and 180 or 170, and we have a student who's 2 meters and 20 centimeters tall, right? 2 meters and 20 centimeters tall, a student. That would be an outlier, right? We could also have somebody who's 80 centimeters tall. Yeah, that would also be an outlier. Okay, so this helps us see outliers. So anyway, now let's move on to how do we do this? So what do we do in the questions? So they say, Ashley, she bought something in the canteen, or he bought something at the canteen. He has to wait in line. 20 visits he made at the canteen, and he counted the number of people in front of him. So he said, right, today it was 7 people in front of him. Then the next day it was 10 people in front of him. Then it was 6 people in front of him. Yeah, I know, right? Shall we make it a bit more interesting? So for every exercise we complete, we will dance a little bit. Yeah. Okay. So anyway, how do we draw a dot plot for this data? Well, all we have to do is basically draw a number line. Eyes on the board. Come on, this is so easy. Now, eyes on the board. Let's see. Numbers down here in the number line. The numbers will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we'll just count. How many ones did we have? Just one. Now, how many twos did we have? Right, so no twos. Yes, well spotted. How many threes do we have? How many fours? Excellent. So notice we have no twos, no threes, no fours. And then we just count the fives. Let's see, we've got 1, 2, 3. Is that it? Yeah, so 3 5s. And then let's see, 6s. 1, 2. Yes, so we have 2 6s, etc. So you get the picture, right? So we just carry on doing the dot plot. Okay, so now the question was, are there any outliers in the data? Well, look at the data. Is there anything that stands out far away from everything else? Yes, that would be the one. So basically the outlier here in this case, are there any outliers? Yes, there is this fella here. This only happened once and it is so far away from anything else, it doesn't make sense. It almost doesn't make sense, right? You wouldn't expect this to happen a lot, basically. That is what this is saying. If I go to wait at the line, I wouldn't expect one person to be in front of me. It would be a little bit unlikely. Okay, right. Now, what was the final question? On what percentage of visits were there more than 8 people in front of Ashley? More than 8 people. Let's see. More than 8 people would be 9 or 10 or 11. Sorry, can you repeat that, please? Because it only happened one time. The 11 happened one time. If you count, there's only one of them, right? And the tens, how many tens did we have? 1, 2, 3. Now, they said on what percentage did we have more than 8 people? 9 or 10 or 11 people. How many dots do you see in there? 9, yes, 9 or 10 or 11 people. How many dots? 6 dots, okay? So 6 times. Now, how many did we have in total, all of the dots all together? Yes. Close. Close. It should be 20. They also said that in the question, right? They said 20 visits. So all the dots all together should add up to 20. So now that would be 6 over 20. So basically now they said, let's change this to a percentage. On what percentage of the times we had 9 or 10 or 11? Well, I think this one we can actually convert into a percentage properly. Yes, when they say percentage, and it can be done easily by simplifying down the fraction, we'll have to do it. So in this case, can we simplify to something over 10? Well, it's 3. So if we divide both by 2, notice we get 3 over 10. So once again, I'll repeat this. Because it's 6 over 20, we can easily simplify the fraction and get 3 over 10. Does it make sense that we can simplify this to 3 over 10? Excellent. So 3 over 10 as a percentage now. What is 3 over 10 as a percentage? Well, 3 over 10 is obviously 30 over 100, which is 30%. So you have another way. What was your way? Oh, yes, absolutely. Yes, I like that as well. 6 over 20, you can do times 5, so you get 30 over 100, which is 30%. Nicely done. Another way would be to say, I can do it by multiplying this fraction, which is 6 over 20. I can multiply it by 100%. And then some students are familiar with how they do this, and they can cross-simplify. 600 divided by 20, maybe you can do it that way, or yeah, but basically in the end you get the same result, 30%. So let's go ahead and do a bit of practice. Everyone, pens and paper. Let's do this. I'm going to stop recording here. Good luck, everyone.